Now in exercise 804, we look at compound interest, and compound interest is different in at least 3 different ways to simple interest, and you really must think about the ways in which it's different. So if we look at the formula for compound interest, it says it's calculated using the formula A equals P times 1 plus R to the n. Now some of you will have seen that before. What makes this such a different formula, apart from that it's got a 1 in it and brackets and n to the power, more importantly than that is the fact that this A, that A does not give the interest. So this is fairly unusual, a formula about interest and the formula doesn't actually give you the interest. Well, that's exactly the situation, and that's what you have to be so aware of. So what does the formula give? The formula gives you how much you would have after a given period of time. So you come along, you invest this lovely little bag of money in the bank, it earns interest, and we say we've deposited P dollars, but after time we collect our bigger bag of dollars because it's earned interest, and it's called A, amount of dollars. So what this formula does is tells us how much in total is in the account now, or is in the investment. So then it's the interest, obviously, is the difference between these two. So A is your bigger number, take away what you put in there, and that is the amount of interest that your investment will have earned. Another way in which this formula is different is because there's actually 2 formulas for an investment, and you may see your amount called the future value of your investment, and that's what FV stands for. PV is the present value, or the amount that was put in the beginning, and the 1 plus R to the n is just the same as the original formula. So that's important as well, that exact same formula can be written in this format. Another way in which it's different is that if we were to graph the compound interest, and so now I'm talking about the graph, you can see that you don't get a straight line, you get a nice little curve. And then just one more variation, and I guess it is a variation, is they don't talk about depreciation. Just a moment. You may see questions where they refer to depreciation, and that's how much an item has depreciated or gone or decreased in value, and you can work out its value, its future value is its present value times 1 minus the rate to the n. So it's actually the presence of this minus in here that makes it a depreciation. I'll stop the video there and do the examples in a separate video.